Now that you've had some practice with the law of sines, we're going to move to finding an angle. So there's a lot more going on than we had to worry about in part one, where you're finding just a side. Now I'm going to give you a little preview. We're going to see how this all plays out, but there's three scenarios when you're finding or solving for an angle. You can get no solution, one solution, or two solutions. Right? So already we don't like it, right? Before it was just you get an answer and you're done. But now we have multiple solutions that could occur. So you'll know when you get there. This is how you can tell. When we're solving our problems, if you get something like this, or you get something like this, or you get something like this. See, this is the point where you should start thinking like, oh, no solution, or there could be one or two, right? We still have to learn it and see what's going on, but this is where you start to notice it. When you have already started solving your law of sines and you get to this point. See, so this is going to be no solution. This is going to be one solution all the time. And unfortunately, this one could be one or two solutions. I would like to tell you that there's always two, but sometimes one of the two doesn't work out. I know that doesn't make any sense right now, but you'll see as we move forward. So I want to talk for a minute about why this is true, right? Why do I even care about this? So I got to get rid of the top portion here. If you remember back when we were studying the graphs of the trig functions, here's the sine wave. And the sine wave, remember, important things happen every 90 degrees. That's the end. The middle would be 180. That peak is 90. And that trough is 270. Now think about the y-axis. The y-axis is 1 and minus 1. Now, these are the x values you plug in, right, sine of this angle, and this would be the y value you get out. Sine never goes over 1. Sine can never be 4.7. It never goes over 1. It never goes under minus 1. So that is, if you see sine being something above 1 or minus 1, those are the best because you're done. You just write no solution and you move on. That is done. If it's equal to exactly 1, there's only one time when that happens. That means that has to actually be a right triangle, and there's only going to be one solution. However, if it's anything between 1 and minus 1, you can pick your spot. In this case, the y value is 0.76. That'd be like right about here. The sine wave at 0.763, that whatever that angle is, that could be it. But so could that. See, I'm getting two solutions there. So it's because of the nature of the sine wave that it goes up and down and repeats itself that you can get multiple solutions potentially. So there's no solutions, one solution, and maybe two solutions. So what we have to do for the remainder of this lesson is we got to just work through these. What would a problem look like so that I get these situations? So let's start with our no solution scenario. The problem would look something like this. I would give you the parts of the triangle. So angle A, we'll say, is 85. A is 15, whatever, inches or centimeters. B is 25. And the directions are solve the triangle. So how do you start these, right? Law of sines is new to me. There's a lot of stuff going on. Draw the picture. Drawing the picture helps us, even though the picture might turn out to be inaccurate, maybe it's an obtuse triangle, maybe there's no possible solution, it's okay. we're just drawing a sample triangle so I can visualize how these givens are oriented with respect to each other. So, for instance, where's the B go? Doesn't really matter. Just pick which side, like if you want that to be B, then this is your 25. If you pick this to be B, it doesn't really matter. All we use the picture for is to get a feel for where things are in relation to each other. So this would have to be C, excuse me. All right, well, remember the key to knowing how to do law of sines is opposing pairs. So I'm sure that I have to use that. So 15 over sine of 85. And I know the 25, so it looks like I'm going to try to get angle B. And there it is. We have an angle for our unknown. We're going to cross multiply. So sine of B, I'm going to use the shortcut, is this product over the number across from the unknown. And that equals, let me grab my calculator, 25 sine 85 over 15. And I get 1.660. See, that's a problem. If sine is over 1 or under -1, that is impossible. If you punch it in your calculator, it's going to error on you. You don't got to memorize it. It'll error on you. But this is a no solution scenario. So if I was supposed to solve for the triangle, my answer would be no solution. I don't even got to bother trying to find the other, like I don't got to worry about C or side C, because if there's no solution, there is no solution. So that's scenario 1. It's actually the nicest one because you get done the quickest. All right, so now let's try one where we get, it feels like there's 2 solutions, but there's only one. All right, well, they're all going to start the same. We just have different givens. So in this scenario, let's say A is 20 point, no. We'll do that one next. A is 48 degrees. Side A is 16, we'll call it inches. Side B is 12 inches. So I draw it. I got my A, B, C. So this is 48, 16, and 12. And I set up my law of sines. So I have opposing pair. Opposing pair, and I get sine of B is 12 times sine of 48 divided by 16, and I'm getting 0.557. Now, to get the angle, I have to do the inverse sine of 0.557 to get angle B. So I'll punch that in. And I'm getting angle B equals 33.85 degrees. Okay, so all is going well. And I'm going to have to find angle C and side C, but let's just pause it there for a minute. See, here's the sine wave, and this is 1, and this is sine equals about a half, right about here. So there's my first one, 33.85. There's another one over here that I got to figure out. See, there's 2 possible angles that give me this answer, 33, and then some other one over here that I don't know what it is. And you could also think of it this way. If you don't like that, remember the sign is, this shows where stuff is positive. This is positive 0.557. So I'm expecting a quadrant 1 angle. Good, the calculator gave me one of the answers, but there should be a quadrant 2 angle also that works for this. So how am I going to get that second answer? That is the tricky part. That's what everybody struggles with. Well, let's draw it. This is the idea of reference angles. If this is my first answer, I want that same size angle in that quadrant because that quadrant is the other place where sine is positive, quadrant 2. So I'm going to draw that angle in quadrant 2. And this is a picture of your second answer. So how would I calculate that? Well, that would be 180. Take away that 33.85. And what's left is the second angle that I want. So that gives me a second angle B, 146.15. Well, how do you deal with that? This is like two alternate realities, right? There's one world where this is the answer for B, and then you know how they got to add up to 180? If this is B, that'll give me a C, and that'll give me side C. And then there's this other possible reality where this is angle B, and if that's B, that'll give me a different C. See how it plays out differently? So we're going to pursue both tracks. And I'm going to label this B1 and B2 for first solution, second solution. Since I'm solving the triangle, I'm going to have to find angle C that goes with this and side C that goes with this. But then I'm also going to have to explore, well, what if angle B was this one? Then what would angle C be? And what would side C be? So I'm done when I figure out all that stuff. And the way I like to play this out is we're going to run down this solution and then put that aside, and we're going to do this solution. So to do this one, if you visualize it, A, B, C, A is 48, B is 33.85, and this is 16 and 12. So this angle's got to be 180, take away those two. So 180 minus 48 minus 33.85, I would get 98.15. Okay, so I found angle C is 180 minus angle A minus angle B. 180 minus those two. How do I get side C? Well, now that I know this angle, see, that's an opposing pair, so I'm going to go law of sines. 16 over sine 48. And side C over sine of 98.15. So C is going to be 16 times this, divided by sine of 48. And I get 21.31 inches. And it took a while to get there, but I just got solution number 1 complete. How do I get solution number 2? Well, we kind of got to backtrack. I know, these are not fun. If we go back to the givens, here, we'll just start a new picture. A is 48. And we now know, even though the picture doesn't fit the angle, this is my other possibility. So this would be 16, and this is 12. There's C. So again, I'm going to go angle C is 180 minus angle A minus angle B. And now look at that for a minute. That should bother you. Other than, you know, that's obtuse, but it doesn't look obtuse. Just look at the numbers. Do you see that you're taking more away from 180 than 180? Or in other words, if you add those up, that's 194 already. So that's not even counting C. So this solution, it felt like I was going to get two solutions, but it doesn't work out because this would exceed 180 degrees for the whole triangle. So in this case, there's really only one solution, even though it started out like there would be two. All right, well, I know I'm probably pushing your attention span. Nice thing about a video is you can press pause, walk away, take a break, but I'm going to keep going here. We got to do our last scenario is what if I get two actual full solutions? So, here we go. Last one. Angle A is 48. Nope, that's what I just did. 20.5. Side A is 12. Let's say centimeters this time. Side B is 31 centimeters. Now this one, we're expecting to get two solutions, so I'm going to set it up over here for solutions. So looking at these, I am done when I have angle B, angle C, and it looks like side C. All right, so I kind of know what to expect. How do I start this thing? It's helpful that I got my picture already because I can see, look, an opposing pair, right? I get very used to that. The more I use the law of sines, the more natural that is. Here, it looks like I'm finding B again, so I have 31 over sine B. So sine B is going to be 31 sine 20.5 divided by 12, and I'm getting 0.905. So now I have to inverse sine that. And the calculator is telling me that my first answer for B, right, this is B, is 64.82 degrees. Right? Calculator says 64.82 degrees. So that's nice. If I was taking a test, if I answered that, I would get half credit. That is definitely part of the answer. The thing is, the sign is positive in quadrants 1 and 2. That's a quadrant 1 angle. I like that. But what about my quadrant 2 angle? How am I going to get that quadrant 2 angle? Well, I got to erase. Here's the one my calculator told me. I want that angle in that quadrant, so I'm going to draw it. And here's a picture of my second angle. And you will notice that that is 180. Take away, literally take away, minus 64.82. And what is left is my second angle. So that would be 115.18 degrees. Now this creates two different possibilities. Normally you don't draw this out, but for clarity I'm going to draw it for you. So here I have two acute angles. So here's scenario 1. So if this is A at 20.5 and this is B at 64.82, well, what else do I know? This is 12 and this is 31. This must be 180 minus those two. So minus 20.5 minus 64.82. And this has to be 94. I know it doesn't look like it, but that's got to be 94 degrees, and that's fine. And now to find this side, if this is 94 and change, well, here's one opposing pair, and I'll use this opposing pair. See, that's the law of sines to get side C. So I have 12 sine 20 equals C over sine 94.68. So C is going to be 12 times this divided by sine of 20.5, and I'm getting 34.15 centimeters, and that locks in my first solution. And I take a breath, and I move over, and I say, well, what about solution 2? Well, solution 2, this is 20.5, except this time B is 115.18. And this is 12, and this is 31. So angle C is going to be 180 minus 20.5 minus 115.18. And that gives me 44.32, and that's fine. That works. So this has a second viable solution. All I got to do is knock off this last side, and I got it. Well, here's my picture. We just figured out 44.32. So here's one opposing pair, and I'm going to use this for my other. 12 over sine of 20.5 equals C2 over sine of 44.32. So our last computation here, C2, is going to be this product. So this is 23.94 centimeters. And there's our full solution. Well, there's a lot to that. You might want to watch this particular lesson more than once. You know, you could throw questions in the comments below, or you could send me an email or Schoology message if you are running into trouble, and we could try to follow up that way. But let's see where that takes us, and I'll be back in touch soon. Have a good one.